Okay, so question number 21. A and B are van der Waals constants for gases. Chlorine is more easily liquefied than ethane because the options are A and B for Cl2 is greater than A and B for C2H6. A and B for Cl2 is less than A and B for C2H6. A for Cl2 is less than A for C2H6, but B for Cl2 is greater than B for C2H6. A for Cl2 is greater than A for C2H6, but B for Cl2 is less than B for C2H6. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number D. So van der Waals constant A is due to force of attraction and B is due to finite size of molecules. Thus, greater the value of A, smaller the value of B. Larger will be the liquefaction. Thus, A of Cl2 is greater than A of C2H6 and B of Cl2 is less than B of C2H6. Hence, option D is the correct answer. Moving to next question, question number 22. The value of compression factor Z for critical constant is, options are 1 by 2, 3 by 4, 3 by 4, 2 by 3 and 3 by 8. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number D. We know that critical pressure is equals to A upon 27 B square. Critical volume will be 3B and critical temperature will be 8A upon 27 RB. So on putting all these values together, PC, VC upon TC will be equals to this. And on solving this, we will find that it will be equal to 3 by 8 R. So the compression factor, that is Z, that is PC, VC by RTC, will be equal to 3 by 8. Hence, option D is the correct answer. Moving on to question number 23. Which of the following exist as crystals in the solid state? Options are iodine, silicon, sulfur, and phosphorus. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number B. Silicon exists as covalent crystal in solid state and it has network-like structure like diamond. So the correct answer will be option number B. Moving on to question number 24. The number of hexagonal faces that are present in truncated octahedron is, options are 2, 4, 6 or 8. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option number D. The truncated octahedron is the 14-faced Archimedean solid with 14 total faces, 6 squares and 8 regular hexagonals. The truncated octahedron is formed by removing the 6 right square pyramids, one from each point of a regular octahedron. You can see here the diagrams. This is a truncated diagram and this is the truncated octahedron diagram. So hence option D will be the correct answer. Moving on to question number 25. The first order diffraction of X-rays from a certain set of crystal planes occur at an angle of 11.8 degree from the planes. If the planes are 0.281 nanometer apart, what is the wavelength of X-rays? Options are 0.281 nanometer, 0.2044 nanometer, 0.1149 nanometer, or 0.1180 nanometer. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be the option number C. We have given n will be 1, d is 0.281 to 10 to the power minus 9 as given in nanometers. So theta will be 11.8. Putting the values in lambda formula, so 2 into the d, 2d sine theta upon n. So it will be coming out as 0.1149. That's why option C is the correct answer. Moving to question number 26. In diamond, the coordination number of carbon is. Options are 4 and its unit cell has 8 carbon atoms, 4 and its unit cell has 6 carbon atoms, 6 and its unit cell has 4 carbon atoms, and 4 and its unit cell has 4 carbon atoms. You have 10 seconds to solve this question. After that, we will see the answer. Okay. The correct answer is option number A. The space lattice of diamond is FCC, face centered. The primitive basis has two identical atoms at 0, 0 and 0 and 1 by 4, 1 by 4 and 1 by 4 coordinates associated with each point of FCC lattice. Thus, the conventional unit cube contains 8 atoms and also diamond is tetrahedral. Hence, option A will be the correct answer. So question number 27. Sodium metal crystallizes in a body-centered cubic lattice with a unit cell edge of 4.29 angstrom. The radius of sodium atom is approximately. Options are 1.86 angstrom, 3.22 angstrom, 5.72 angstrom, and 0.93 angstrom. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number A. Here you can see the diagram of the situation depicting in the question. So from this figure, AC square, this square will be equal to AB square plus BC square according to the Pythagoras theorem. So A square plus A square will be 2A square because we have a cubic lattice. And also AD square will be equal to AC square plus DC square. So on solving the equations and putting the values of AD, AC, DC, BC, and AB and AC, we have R will be equal to under root 3 by 4A. Now, when sodium metal crystallizes in BCC unit cell with unit cell edge length A, that is 4.29 angstrom, R will be root 3 divided by 4 multiplied by A, that is 4.29 angstrom, and coming out as 1.86 angstrom. Hence, option A is the correct answer. Moving on to question number 28. Lithium forms body-centered cubic structure. The length of the side of its unit cell is 351 picometer. Atomic radius of the lithium will be. Options are 75 picometer, 300 picometer, 240 picometer, 152 picometer. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option is option number D. So atomic radius of lithium will be under root 3 by 4A according to the formula, as this is body-centered cubic. So putting the equation of A, we have the value of 152 picometer. Hence, the option D is the correct answer. Moving on to question number 29. Cesium chloride crystallizes in body-centered cubic lattice. If A is length of edge, then which of the following expressions is correct? R of CS plus R of Cl will be 3A, will be 3A by 2, and will be under root 3 by 2A, or will be under root 3A. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So, correct option is answer number C, that is option C. So, cesium chloride crystal has BCC structure like this. So, AD square will be AC square plus CD square. Putting the values, we have AD will be equal to A root 3, and also AD is R of Cl negative plus 2 R of CS positive plus R of Cl negative. So, it is coming out as A root 3, and as R of Cl negative is coming out 2 times, so 2 will become 2 will be coming in denominator, and this equation will be equal to root 3 by 2 into A. Hence, option C is the correct answer. Moving on to question number 30. If a face-centered cubic lattice, atom A occupies the corner positions and atom B occupies the face-centered positions. If one atom of B is missing from one of the face-centered points, the formula of the compound is. Options are A2B, AB2, A2B2, or A2B5. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So correct answer is option number D. So number of atoms of A per unit cell will be 8 multiplied by 1 by 8, that is 1. And number of atoms of B per unit cell will be 6 minus 1 multiplied by half, that is 5 by 2. Since one atom of B is missing, the formula will be A1 B 5 by 2 or A2 B 5. Hence option D is the correct answer. Moving to question number 31. An element having an atomic radius of 0.14 nanometer crystallizes in a FCC unit cell. What is the length of the side of the cell? Options are 0.56 nanometer, 0.24 nanometer, 0.96 nanometer, and 0.4 nanometer. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer will be the answer D. So for FCC unit cell, R will be equal to root 2 by 4A. So 0.14 will be equal to root 2 by 4A, and A is coming out as 0.4 nanometer. Hence option D is the correct answer. Moving on to question number 32. If the distance between sodium positive and chlorine negative ion in NaCl crystal is A picometer, what is the length of cell edge? Options are 4A, A by 4, 2A, or A by 2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, the correct answer is option number C. As length of edge of NaCl unit cell will be equal to 2 into distance between Na positive and Cl negative, that is 2A picometer. Hence option C is correct answer. Moving to question number 33. A metal crystallizes in a face-centered cubic structure. If the edge length of its unit cell is A, the closest approach between two atoms in metallic crystal will be. Options are 2A, 2 root 2A, root 2A, A by root 2. We have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer is option number D. For FCC arrangement, 4R will be equal to 2 under root 2A, where R is radius and A is the edge length. The closest distance will be 2R, that is root 2A by 2, and it will be coming out as A by root 2. Hence option D is the correct answer. Moving on to question number 34. How many unit cells are present in a cube-shaped ideal crystal of NaCl of mass 1 gram? Options are 2.57 into 10 to the power 21, 5.14 into 10 to the power 21, 1.28 into 10 to the power 21, or 1.71 into 10 to the power 21. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number A. The mass of one unit cell will be V multiplied by D, that is A cube multiplied by D. So density will be Z into M upon A cube into N naught. So mass of one unit cell will be A cube multiplied by Z multiplied by M upon A cube multiplied by N naught, which is coming out as Zm by N naught. N naught is basically like Avogadro's number. So putting the values, we find out that mass of one unit cell is 38.87 into 10 to the power minus 23 gram. So number of unit cells in 1 gram will be 1 upon 38.87 into 10 to the power minus 23. That is coming out as 2.57 into 10 to the power 21. Hence option A is the correct answer. Moving on to question number 35. Iron crystallizes in a BCC type system with a lattice parameter of 2.861 angstrom. Calculate the density of iron in the BCC system. Atomic weight of iron and the Avogadro's number is given. Options are 7.94 gram milliliter inverse, 8.96 gram milliliter inverse, 2.78 gram milliliter inverse, or 6.72 gram milliliter inverse. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number A. Density we know is will be equal to Zm upon Avogadro's number multiplied by the cube of the edge length. So for BCC, Z is equals to 2. Putting out the numbers or values in the formula of density, we are coming out as D is equals to 7.94 gram centimeter cubic inverse. Hence, option A is the correct answer. Moving on to question number 36. Calcium crystallizes in a face-centered cubic unit cell with A equal to 0.556 nanometer. Calculate the density if it contains 0.1% Schottky defects. Options are 1.5463 gram per cubic centimeter, 1.4962 gram per cubic centimeter, 1.5448 gram per cubic centimeter, or 1.5943 gram per cubic centimeter. You have 10 seconds to solve this question. After that, we will see the answer. So the correct answer will be option C. So D formula, density formula is this. Putting out the value, we are calculating Z value, that is 3.996. Because it contains 0.1% Schottky defects, D will be this, which is coming out as 1.5448 gram per centimeter cubic. So option C is the correct answer. Moving on to next question, question number 37. To get N types semiconductor from silicon, it should be doped with a substance with valence 1, 2, 3 or 5. You have 10 seconds question. You have 10 seconds for solve this question, and after that we will see the answer. Okay, so the correct answer is option number D. For the preparation of N-type semiconductor from silicon, it should be doped with a substance of 5 valence electrons. So the option D is the correct answer. Moving on to question number 38. Which type of defect has the presence of cations in the interstitial sites? Options are Schottky defect, vacancy defect, Frankel defect, or metal deficiency defect. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number C. It is the Frankel defect in which cations leave their original site and occupy interstitial site as shown below in the diagram. You can see the cation is leaving their original site and occupy interstitial site. Moving to question number 39. Which of the following compound is metallic and ferromagnetic? CrO2, VO2, MnO2 or TiO2? You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number A. Only 3 elements, iron, cobalt and nickel, show ferromagnetism at room temperature. CrO2 is also a metallic and ferromagnetic compound which is used to make magnetic tapes for cassette recorders. Hence, option A is the correct answer. Moving to question number 40. So we have given the direction, that is in the following questions, assertion and followed by region is given. Choose the correct answer out of the following choices. Assertion is average speed of molecules if a gas in a container moving only in one direction will be 0. And reason, the molecules of gas are not collected in one direction. The options are both A and R are true, and R is correct explanation of A. Both A and R are true, but R is not correct explanation of A. A is true, but R is false. Both A and R are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So correct option is option number A. So both assertion and reason are true, and reason is a correct explanation for the given assertion because motion of gas in one direction gives 0 average speed. Moving on to question number 41, we have given again assertion and reason. Assertion: the temperature at which vapor pressure of a liquid is equal to external pressure is called boiling temperature. And the reason is at high altitude, atmospheric pressure is high. So both A and R are true and R is correct explanation of A. Both A and R are true, but R is not correct explanation of A. A is true, but R is false. And both A and R are false. We have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer is answer number, option number C. Assertion is true, but reason is false because at high altitude or a high altitude, the atmospheric pressure is low, not high. Hence, option C is the correct answer. Moving on to question number 42. Assertion reason is given. Assertion is liquid tends to have maximum number of molecules at their surface. Reason is small liquid drops have spherical shape. Options are both A and R are true, but R is correct explanation of A. Both A and R are true, but R is not correct explanation of A. A is true, but R is false. Both A and R are false. We have 10 seconds to solve this question. After that, we will see the answer. Okay. The correct answer is option number D. So both assertion and reason are false. Liquid tends to possess a minimum number of molecules on the surface due to the surface tension. And reason given is also the not the correct reason for the assertion. So option D is the correct answer. Moving to question number 43. So assertion and reason is given. Assertion is solids containing F centers are paramagnetic. Reason: F centers solids possess holes occupied by unpaired electrons. Options are both A and R are true and R is correct explanation. Both A and R are true but R is not correct explanation. A is true but R is false, or both A and R are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number A. Both assertion and reason are true, and the reason is a correct explanation for assertion because F centers contains unpaired electron and show paramagnetic character. Okay, thank you.